Physics2Lab4. Our goal for this lab was to understand the principles behind circuits through construction and measurements. For example, like with the current, where we found our current is 0.017 amperes. I found that the greater the resistance, the longer the time for the capacitor to charge and thus discharge. And our system is the ammeter or voltmeter, and the surroundings is the circuit, but you could consider the surroundings as everything but the ammeter or voltmeter and the circuit. Here's a picture of our circuit. And here are some of our equations. We have our node rule, where considering that we are completely in series, all the way around the current is going to be equal. We also have the loop rule, so the potential difference going from one point in the loop all the way back around will be 0. We also have equation to find our resistance, and the capacitance as well. Using our known values of resistance and battery, we did find that our expected value should have been 0.02, but in reality it was closer to 0.017. But also, if you were to reverse these, it would just end up being the negative version of that number. Here's a nice little drawing of our circuit, and also the red values are our potential differences all the way around. So as you can tell, according to the node rule, everything should be the same. However, we did actually find that it was 0.042 off, which could have to do with incorrect measurements, or the wires weren't as negligible as we were led to believe. And then I also found the resistance, if we were to use the known values and our calculated I value from the last slide, I found that the resistance would have been closer to 48 for the 47 ohm resistor right here, and for the 100 ohm resistor right here would have been closer to 101, but that's quite similar. And then next we have our RC circuit, where we were told to have our little circuit here where we charge the capacitor with a battery here, then unhook the battery and put a light bulb in and see how long it would glow. And we did this a few times to get these average recorded time of 7.24, and it was found that the expected value should have been about 0.5, and the actual value was 0.44459, so rounding up, it would be somewhat close, actually. Finally, we come to our what if questions, and they take into account whether that we could have done it virtually, and that previous classes did do it virtually, but we didn't do it in real life, so some of these answers are going to be edited for that. So what if we had used an actual ammeter instead of an ideal simulated ammeter? That would actually have caused possible errors. For example, moving your ammeter probes just slightly in any sort of direction can change values, while an ideal simulated ammeter would most likely get the correct values every time. And for the next one, if you were to do the lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit, how quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? If we did have a resistor, we would expect it to go a lot more slowly than without a resistor, due to the fact that, of course, the flow is impeded slightly. And finally, I did not have a slide for this, but we would actually have some sources of possible errors. with of course the fact that again the ammeter and voltmeter values could be slightly off and the wires could have some actual potential difference change in them that we did not take into account.